Okay, students, thank you to Abdul Rahman who gifted me a device where I can write, I can use my mouse, and I can make some, like, say, fancy drawings. Okay, so let's try and continue the lectures. So let me quickly recall what we were studying. We were studying finite automata with outputs, and there are two particular types, like Moore machine and Mealy machine. Moore machine is a machine with the 6 tuples. We have a set of states, we have initial state, we have the set of alphabets, we have set of alphabets, output alphabets, we have a transition function for input strings, and then we generate an output string for a given from the given states. Every state gives some output. So this is the example. We can see that. So if let's say my string input is, like, say, if I have my string input is AB, then if I'm on a Q0 and I just get a, then I get to state Q1 and output is 0. This 0 is produced. In my last lecture I almost forget that for given input string we get the output string till here, but in a Moore machine there is one special output like this, which is not in the case of a Mealy machine. This gives the extra output, which means it can accept even an empty string. For example, if I give nothing, empty string, then even then you will be on the initial state and you will give the output 1. So this is just one thing I was missing in my last lecture. So this is an example. You give an input, you get an output. When you reach from state 1 to another state, and whatever is the output, you report that. For example, you get A from Q0, you come to Q1, and this is the output. So for every corresponding input we have an exactly one output, but without reading anything we can generate an output in Moore machine. And last example we saw one machine where we were inverting any given binary string, like for example, if I can recall, so sorry, yeah, so here that's a simple machine. This is still, my writing is not very good in this, I have to get used to it. If you get 0, the output should be 1. If you get 1, output should be 0. So if you get 1 here, output is 0, and when you get 0, the output is 1. This is a very simple machine with 2 states only, and whatever the binary string you will give, it will invert the string. The output will be an inversion. Just for example, if I give 1 0 0 1, the output will be 0 1 1 0, and we will have one prefix 1, which is the, without reading anything we produce something. This is an example of Moore machine. We can make many famous, there is another machine that counts exactly the number of AABs appear in a very long string. If you have a very long string, combination of A and B, this machine counts how many times double AB appears exactly in the machine. For example, if this is my input string A, B, A, B, B, A, B, B. So the output is, if you just traverse using you make a transition table, or without just looking at the diagram, you can traverse this string. So what happens when you are at Q0, you read nothing, but you give the output 0, right? This is just something very fancy here. And when you read A1 or at Q1, you get 0 0, and whenever this pattern repeats, this is the pattern we want to see. If this pattern repeats, how many times this pattern repeats. So this pattern can be in a real life anything abnormal, and we want to see if anything abnormal have happened. Okay, so but as a concept we will see very simple example, a pattern of string A and A, B. But when we implement a complex Moore machine, then we take a functions. If the set of functions consecutively happen, then it means this is something very serious we should take care of. Anyway, this is a machine, this is a string input, and this is my output. If you at the end you sum, you will get 2 times a b is repeated in the string, and you can cross check. Okay, in contrary to Mealy machine, what is the difference between Mealy and Moore machine? In Moore machine, for example, this is my initial state, this is my state name, and there is an output here. But in case of Mealy machine, we have 2 states. You can go from here to here, and let's say from here to here. The states do not give the output, but the transition, the edges gives. For example, if you get A, the output is 0. If you get B, output is 1. And then you balance the machine to make it, for example, from B we get for 0, and for B here we get 1. So this is the Mealy machine, where the output is given when you read an alphabet, and the edges decide what is the output, whereas in the Moore machine the state used to decide what is the output. So the property of Mealy machine, the easiest way to detect either this is the Moore machine or Mealy machine is that for given input, for example, if I give A, B, the output will be 0. This should be A. Output should be 0, 0, 1. So the length of input and the length of output should be the same. This is the easiest way to decide, to just look the input and output length. If the same, then we say this is the Mealy machine. If the length is not same, then we say this is the Moore machine. And of course we can convert Mealy to Moore machine and Moore to Mealy machine. So this is 1, 2, 3, 4, 5, 6, again 6 tuple machine. Most of the things remain same. This is again present in Moore machine also. The set of states Q0, initial state, is present in Moore machine. Sigma is present in the Moore machine. Output alphabets is present in the Moore machine. Delta function is there, same as a Moore machine. But this is a difference. See, before at the state Q we were getting the output, but instead from the state whatever is the input string, that decide what is the output. So in my coming quiz you will have to understand what this tells us. This type of notations should be interpretable to all of you. If you have a confusion, do ask the questions. In my last lecture I also mentioned that please ask the questions. So if you ask the question, then I will know I have to explain them. So what does it tell you? Okay, for example, if I have a function that is a plus, so this is the function plus. What the plus does, it takes, let's say, whole number into whole number, and the output is the whole number. So what does it mean? Oh, sorry, it's okay. So what information it is giving us? So you should be able to understand these types of notation. So this is another example of Mealy machine, how the Mealy machine actually looks like. So you can see from Q0 to you come to Q1, the output is not at the state, but the output is given at the edges. When from Q0 to Q1 you come, that the output is 0. So let's complete what are the Q here. Q is Q0, Q1, Q2, Q0, Q1, Q2 and Q3. And what is the sigma? Sigma is A and B. What is the output alphabets? Output alphabets are 0 and 1. And what is the transition function? For transition function you can draw a transition table, and the output symbol for the G is if you are at state Q0 and you get alphabet A, then the output is 0. Instead of state we will get the output. This is how we try to expand the G. Okay, Finite automata with output. This is again with the four states machine, and we can see this is the input, this is the output. The length of both are the same. The length of this both input and output should be the same in case of Mealy machine. So this is the example of complement or inversion of the binary string. If you give 0, it gives the output 1. If you give 1, this gives the output 0. In case of Moore machine, we need at least 2 states, but the same language can be implemented using Mealy machine with the 1 state. So just check. If you give A, output is X. If you give B, the output is Y. So this is an increment machine. Whatever the number you give of 4 bits, so it will increase the number. If you give 1, it will give the output 2. If you give 2, the output will be 3. If you give 3, the output will be 4. Just check either it is true or not. So you have to get a binary number, let's say 10, and if you execute, the answer should be for example, if you give 10, 10 is 2 raised to the power 0, 2 raised to the power 1. So then when you run this example on this, you will get 1 increment on the machine. The next topic is conversion from Moore to Mealy and Mealy to Moore. So there are 2 topics: converting Mealy to Moore and Moore to Mealy. So one topic I will explain, the easy one I will explain, and the difficult or the tricky one is left for homework. Okay guys, see you in my coming lecture how to convert Moore to Mealy and Mealy to Moore.